Okay, today I'm covering lesson 16, and lesson 16 is all about something called the mean value theorem, and this ties into lesson 15 and 17 on characteristics of a function's graph using the first and second derivative test to find those said characteristics. So lesson 16, let me go over the actual theorem, and then we'll jump right into some examples. Theorem 4, the mean value theorem. Suppose y equal to f of x is continuous over a closed interval ab, as pictured over here, and differentiable on the interval's interior ab. Then there is at least one point C in your open interval AB such that when you take the derivative at C, or f prime of C, then that's equal to basically the slope formula. F of B minus f of A over B minus A. So according to the picture, there should be some C here in between A and B, as I mentioned, where your derivative, your first derivative, is equal to your slope. What that means is here is the tangent line at f of c, and here's the secant line going through our f of x curve. The mean value theorem guarantees that there's some point C that will make not only these two lines parallel, but these two lines will have the same slope. So let's jump right into our first example. Find the value or values, there could be more than one, of C that satisfies the given equation in the conclusion of the mean value theorem for the given function and interval. So we have f of x equal to x square root of x minus 8 over the closed interval from 8 to 15. The first thing we need to find is f of b, and by the way, a is 8 and b is 15. So to find f of b or f of 15, just go to your original function and replace your x with 15. So f of b is square root of 7. Next, we need to find f of a. And a is 8. And again, in your original function, replace your x this time around with 8. So we have 8 minus 8, which is square root of 0, or just plain old 0. Now let's plug everything in. Well, before we do that, we need to find f prime of c also. And all you do in your original function, everywhere you see an x, replace it with c. So we have the square root of c minus 8 which is really c minus 8 to the 1/2 power. Well, we got to find f prime of c, so we got to take the derivative. Using first the power rule, we'll move the 1/2 to the front, bring down our c minus 8, and to finish up the power rule, we subtract 1 from the 1/2, and that gives us negative 1/2. And we need to use the chain rule as well. So we take the derivative of c minus 8. Well, the derivative of c is just like the derivative of x. That's 1. And the derivative of negative 8 is 0. Now, let me bring down our equation. And let's plug everything in. All right, so f of b was square root of 7. F of a is 0. All over just b minus a, which is 15 minus 8. And before we plug in f prime of c, we need to change this part of our derivative back into a radical. So that will become now 1 over 2 times the square root of c minus 8. Now let's simplify a little bit before we find c. We have square root of 7 over 7 equal to 1 over 2 times the square root of c minus 8. Now we have a proportion, so we could either cross multiply or we could just do regular multiplication. So let's see which one will be best here. Now when you cross multiply, 1 times 7 is just 7. And then we got on the other side 2 times square root of 7 times square root of c minus 8. Now we can put the square root of 7 inside the c minus 8. So that would be square root of 7c minus 56. Now, to solve the radical part, you do the opposite of taking the square root, which means you square both sides. And yeah, we're squaring that too also. So that gives us 49 equal to 4 times in parentheses 7c minus 56. Now we need to distribute that 4 before we solve for c. And that gives us 28c minus whatever 56 times 4 is. That's minus 224. Now let's add 224 to both sides. and see what we come up with. On the left side, that would be 273 equal to 28C. And when we divide both sides by 28, let me see if 273 and 28 can be reduced. Hang on just a minute. 273 by 7. Yeah, actually 273 and 28 are both divisible by 7. So that would give us 39/4 for C. Now, we need to check and see if C is between 8 and 15. So 39 divided by 4 is 9.75. So this value for C will indeed, because it's between 8 and 15, it will satisfy the mean value theorem. And this particular point of C is what would make not only your tangent line at f of C uh, the same as the secant line, but they will be parallel. All right, let's look at another problem. The next one involves a natural log. Same directions. Find the value or values of C that satisfy the given equation in the conclusion of the mean value theorem for the function and interval shown below. So we have f of x equal to natural log of, in parentheses, x minus 3, going from the closed interval 4 to 10, where a is 4 and b is 10. First order business, let's find f prime of c first. But we have to replace each x in our original function with c. So we have natural log of, in parentheses, c minus 3. Now, when we take the derivative of c, remember the natural log of a given function is 1 over that given function times the derivative of that given function. So the derivative of c minus 3 is just 1, giving us f prime of c is exactly 1 over c minus 3. Now let's go back and find f of b and f of a. F of b, b is 10. So this time around, replace every x in your original function with 10. That would be natural log of 10 minus 3, which is natural log of 7. Next, find f of a, with a being the value 4. Go back to your original function, and this time around, replace each x with 4. So that is natural log of 4 minus 3 in parentheses. We get natural log of 1, and natural log of 1 is 0. So let's plug everything into our equation. Hang on just a minute. Let me copy and paste it. All right. F of b is natural log of 7. So natural log of f of b, which is natural log of 7, minus f of a, which is 0, so you don't need that, all over b minus a, or 10 minus 4, and that's equal to f prime of c, which was 1 over c minus 3. And let's finish the problem and find our c. This will give you natural log of 7 over 6 now. We have a proportion, so let's cross multiply. So we have c minus 3 times natural log of 7 equal to 6. Now, to make finding c a little bit easier for us, let's divide both sides by natural log of 7. We're now left with c minus 3 equal to 6 over natural log of 7. And to isolate c, or get c by itself, let's add 3 to both sides. And we get 6 over natural log of 7 plus 3. And off screen, let me pull up my calculator and put this answer in and see if our answer falls between 4 and 10. So 6 divided by natural log of 7 plus 3. As a decimal, our answer is roughly 6.08. So yeah, because that falls in between 4 and 10, then our C would satisfy the mean value theorem. All right, let's look at another problem. Hang on just a minute. Let me screenshot it. Question 3. And I'll just mark our answer here. Does the function satisfy the hypotheses of the mean value theorem on the given interval? Give reasons for your answer. So we're given f of x is equal to the square root of, this is all under the radical, x times, in parentheses, 3 minus x, from the closed interval AB, going from 0 to 3. First thing we need to find is our derivative. Now, let me explain the answer. What the answer means is that f of x is a continuous or smooth curve everywhere from 0 to 3. And the differentiable part means that we can find some c that's between 0 and 3 that satisfies the mean value theorem. So, having said, now that we know that, let's find f prime of c first. And I am going to do two things here. Number one, distribute that first c. So that would be 3c minus c squared. And I'm going to write this all as to the 1/2 power. All right, so let's take the derivative. And we'll be using combination chain rule and first up power rule. So power rule will move the 1/2 to the front, bring down what's in parentheses. With the power rule for derivatives, you always subtract 1 from the original exponent. So that would be to the negative 1/2 power. And here's where you introduce the chain rule by taking the derivative of what's inside your parentheses. So the derivative of what's inside the parentheses is just 3 minus 2c. Now let's rewrite this. The first thing I'm going to rewrite is this part here I've just boxed in. Let's rewrite that back with a positive exponent or square root. So that would be in the denominator 2 times the square root of 3c minus c squared. And our numerator is just 3 minus 2c. Now let's find f of b and f of a. Will be as 3. And we'll just plug in our original function. Everywhere we see an x, we'll plug in 3. And that actually goes to 0. Next, find f of a, with a being 0, and do the same thing. Go back to your original function and replace each x with 0. And that will also give you 0. So let me write down our equation and then plug everything in. F of b minus f of a, well, that's just 0, 0 minus 0, all over b minus a, or 3 minus 0, equal to f prime of c. Now, let me erase a little bit of the left side of our page. So the left side of our equation, we have 0 over 3 equal to 3 minus 2c all over 2 times square root of 3c minus c squared. Now the entire left side is actually 0. And when we actually cross multiply, then what I just circled will become 0 as well. And let's just solve for c. I'll subtract 3, or you can add 2c to both sides. It does not matter. And that gives us 2c equal to 3. And the last step, let's divide both sides by 2. Therefore, c is equal to 3 halves, or 1.5. 1.5 is in between our closed interval 0 to 3. So we can accept 3 halves, or 1.5, as our value for c. Again, what this means is, because we found a value for c that falls in our given interval, then that means our satisfies the mean value theorem, and it also denotes that our function is continuous over the closed interval and differentiable on the open interval. Let me get our next problem on deck. Oh, hold on just a second. Okay, hang on just another minute. I was trying to read the problem and copy and paste it at the same time. All right, it took 18 seconds for a mercury thermometer to rise from negative 35 degrees Celsius to 100 degrees Celsius when it was taken from a freezer and placed in boiling water. Show that somewhere along the way the mercury was rising at a rate of 7.5 degrees Celsius per second. So we're going to use the mean value theorem, and we're not given a closed interval, but actually we are, but not in the form we're used to. It says at the very beginning of our problem, it took 18 seconds for a thermometer to rise. So we're assuming that's at an initial time of 0, as stated right here, as a matter of fact. So our closed interval is going from 0 to 18. And first question is f of t, t representing time, continuous on our closed interval going from 0 to 18? And the answer is yes, because there are no jumps in temperature. It goes linearly from negative 35 to 100 degrees centigrade. There are no jumps in temperature while the temperature is changing, and there are no values that the temperature must skip over. In other words, no points of discontinuity. Okay, so that part was pretty easy to answer. Let's look at the next part. What does f prime of t represent for this application? And C is the correct answer. Is the rate of change of temperature with respect to time. Remember our basic definition of derivative back at the beginning of the semester. Derivative means change in values. All right, next question. Is f of t differentiable on the open interval 0 to 18? The answer to this question is yes, because the rate at which the temperature is changing, it doesn't change suddenly from one value to another. In other words, it's not doing some crazy stuff. It's just like a smooth transition from one temperature to the next. So all the conditions of the mean value theorem are satisfied. Continuous, closed interval, differentiable on the open interval. The next thing we need to find is using our equation, f of b minus f of a all over b minus a. So we need to figure that out because we're already given this side of our equation. That is our derivative of c per se. So let me copy and paste our formula. Oh, sorry, I actually got it here. Excuse me. F prime of C we're already given. That's 7.5. we need to find f of b and also f of a. So f of b, I had to think about it just a minute. Think back to our closed interval we found was from 0 to 18. So that means A is 0 and B is 18. So f of b, or f of 18, is actually 100 degrees. F of a is f of 0, and that is negative 35 degrees. So let's plug everything into our equation. We got f of b minus, now because our second temperature is negative, and we already have a negative in our equation, we got a double negative happening up top. All over b minus a, or 18 minus 0. So that gives us 135 over 18. And let me see what that equals to. That's exactly 7.5. So I think we have proven, let me double check. Yeah, our left side, we just found it to be exactly equal to our right-hand side. So we proved that there is a rate somewhere where it's 7.5. So there is at least one point in conclusion of our mean value theorem. There is at least one point C in your open interval AB at which f prime of C is equal to 7.5. The last part of our question, interpret what there is at least one point, what I just read, means for this application. Choose the correct answer below. Be careful because C looks like it may be the correct answer. But remember, 7.5 is not seconds, it's actually a rate, degrees Celsius per second. So D is the correct answer, or correct interpretation. There is at least one point in time between 0 and 18 seconds at time C when the temperature is rising at 7.5 degrees Celsius per second. I want to go back and look at one more question each of one involving natural logs again, and one involving a square root. So let's try this one again. Find the value or values of C that satisfy the given equation in the conclusion of the mean value theorem for the given function and interval. F of x is square root of x minus 6. Over the closed interval going 6 to 13, where 6 is A and 13 is B. First up, everywhere in your original function that you see an x, replace it with c. And the square root of c minus 6, we're going to rewrite that as c minus 6 to the 1/2 power. That way it's easier to take the derivative. So when we take the first derivative, we have 1/2 times c minus 6, and we have to subtract 1 from 1/2. That gives us negative 1/2. And then don't forget, using the chain rule, you got to take the derivative of your c minus 6. The derivative of c minus 6 is just 1. Now, let's rewrite this back in radical form. And it will be now 1 over 2 times the square root of c minus 6. Now we need to find f of b, b as in boy, and f of a. So in your original function, replace each x with 13. That's the value of b. And that will give us square root of 13 minus 6, or just square root of 7. And next up, plug in f of a with a being 6 into your original function. And that would just give you 0. Now let's plug everything into our equation. Hang on just a second. Let me copy and paste it so we can use it. All right, f of b minus f of a is square root of 7 minus 0, which is square root of 7, all over b minus a, or 13 minus 6, equal to f prime of c, which is 1 over 2 times the square root of c minus 6. Now let's cross multiply. And this is 7, by the way. So we got 7 equal to 2 times square root of 7 times square root of c minus 6. And to get rid of the radicals, let's square both sides of our equation. All right, so 7 squared is 49. 2 squared is 4. And the square root of 7 squared is just plain old 7. So that would just be 28. And the square root of c minus 6 squared is just c minus 6. Now, to make it easier on us, I'm actually going to divide both sides by 28. Because 49 over 28 is a little easier to reduce, divide both well, 7 can go into both numbers. So we got 7 over 4 equal to c minus 6. Now let's add 6 to both sides. And on the left side, 6 plus 7/4 is actually 6 7/4. And you can easily change that into an improper fraction by, from arithmetic, just converting your mixed number to an improper fraction, the usual way. 6 times 4 is 24, plus 7 gives us 31 over 4. And 31 over 4 is roughly 7.75, I believe. And 7.75 is between 6 and 13. So that means our C that we found satisfies the mean value theorem. Let's see what this information all looks like graphically. So hang on just a minute. I'm going to Desmos. Let's see, f of x equal to the square root of x minus 6 and we're only concerned with the little piece going from, hold on just a minute. Okay, we're only concerned with the interval going from 6 to 13. So I just kind of drew that. Let me draw that a little bit better here. So that's saying there's a number C that will make our tangent line at f of c and our secant line, let's see, 7.75 is roughly here. And it's a really rough, horrible sketch. But 7.75 is what will make the tangent line and the secant line parallel and have the same slope. So that's what the mean value theorem actually means. Let's go back and look at one more problem involving natural log. And let me also copy and paste our equation. All right. First thing, replace each x with c. So we have f of c equal to natural log, in parentheses, oh, sorry, that should be a C there. Now we can take the derivative of C. So f prime of C is equal to 1 over C minus 1 times the derivative of C minus 1. And the derivative of C minus 1 is just 1. So f prime of C is just the fraction 1 over C minus 1. Next up, let's find f of b. And according to our given closed interval, b is 4. In your original function, replace each x with 4. And that gives us natural log of 3. Do the same thing to find f of a, but this time around replace each x with a's value of 2. And that is natural log of 1, which is 0. Now let's plug everything into our equation, starting with the top. We have natural log of 3 minus 0, which you don't need to put that, all over 4 minus 2 equal to f prime of c, or 1 over c minus 1. Of course, the 4 minus 2 is equal to 2. Now, because we have a proportion, let's cross multiply. So we have 2 equal to c minus 1 times natural log of 3. Now, to make it easier to find our value for c, let's first divide both sides by natural log of 3. That will give us 2 over natural log of 3 equal to c minus 1. And the final step, just add 1 to each side. That gives us 2 over natural log of 3 plus 1 for our letter C. Now, in order to satisfy the mean value theorem, C has to fall in our closed interval. So off screen, let me calculate. Let me put this in my calculator and see what we get. As a decimal, this is roughly 2.82. And that is in between 2 and 4. So we have satisfied the conditions of our mean value theorem. Look for this video on the mean value theorem, lesson 16, in Blackboard announcements, either later on today or first thing tomorrow.